So today, as everyone knows, we're going to be talking about fly management on an organic dairy specifically. And I just wanted to talk a little bit about how this workshop came about. Andre Brito and many of his collaborators at UNH received a USDA Organic Research Education Initiative Planning Grant 2 years ago? About 2 years ago, and the goal of that grant was to do a needs assessment of organic dairies, and one of the primary needs that floated to the top was more information on organic fly management. So this workshop is actually that team taking what you said you needed and trying to basically put together a series of information on that. So again, this will be posted online if you miss anything and you want to watch that. So if the folks from UNH could raise their hands, that would be great. Andre and Dave, I guess you guys were the only two that came up today. Everybody's busy. So we have a great lineup of speakers from really around the country: Minnesota, Cornell, and North Carolina, the best fly experts we could find. And flew them all here, and they got to stay here at the Inn at Essex. It's a very nice spot. So the first person to speak on our agenda this morning is Roger Moon. And Roger teaches and conducts research in veterinary entomology at the University of Minnesota. How's it in Minnesota?
Raining last I heard.
Oh, but that's probably good. Did you need rain there? You still need rain. So welcome, Roger. Roger and his students have studied dung beetles, something that I get a lot of questions about. Actually, I don't know much about it, so I'm glad you're here, Roger. And biological control with parasitic wasps and effects of weather on filth flies around grazing cattle. So thanks, Roger, for being here, and I'll let you take it from here. And I think, is there a pointer, Dad? Do you know? No pointer.
Our instructions were to use the...
Oh, okay, you're way ahead.
Thank you for that gracious introduction, and thank you all for coming here. I think it's Herculean that you would leave what's growing to be sitting in this hot converted barn and listen to people talk about flies, but we'll take that as an indication that you're actually interested, and I hope so. I've put together what I'm going to call the warm-up act for this trio here. I'm calling it Bugs 101 for dairy fly management, or if you want to take home another way to think about it, the basic message is to know that there's a variety of different insects out there that can affect your dairy animals and your comfort, and know your enemies, be able to distinguish among them, and then pick the right battles. I think an important point is that there are a couple that we have strong evidence affects the economics of the dairy cows enterprise. And in turn, if you see some management options that you can work into your operation, we think they will pay for themselves and will be profitable improvements in your summer dairy cow management program. But first, let's deal with what all is out there. Nature has produced an enormous diversity of insects and other arthropods. These are animals with 6 or 8 legs, exoskeletons. These are things that you learned about, hopefully, in high school biology. But there's way too many to put names on all of them for normal mortals like us. It's easier to think of them as members of functional groups. And I've listed 4 here that you, I think, should be aware of and manage to get their benefits or minimize their harms. We have decomposers. These are the dung beetles and others. These are important for cycling nutrients on your farm, breaking down dung and so forth. I'll illustrate some of those in a moment. Spend the bulk of our time talking about pests. There are different kinds. Some are flies, others. It's important to be able to distinguish among them. And then there are beneficials out there too, things that we recognize are important natural enemies. We want to conserve these, if not augment them, in a way to get the benefits of free or low-cost pest control. Then finally, there's a whole bunch of other things out there that we're pretty ignorant about. They're probably not major importance, but just be aware that they are around your farm. You probably know them already. Here's an example of some of the decomposers, the prominent ones. We get a lot of questions about dung beetles, and I've shown 2 examples here of the kinds of beetles. In the center, front and center, anybody know how often a cow defecates? About every 2 hours. Times the number of animals, how many deposits are there on your pastures, or worse, in your barns, right? Those are the ones you have to shovel out, but it's the time out there during the summer when they're grazing. That dung would accumulate were it not for nature's decomposers. And the big ones are dung beetles, but there are also earthworms that are resident in the soil, and these things are helping break those dung pats down, release the nutrients, make them available for plant growth, and to reduce littering. You see in the lower right-hand corner what looks like some piles of bran flakes. Those were intact dung pats, and they've been worked by little tiny beetles that fly, smell, and colonize, and this is actually the substance for their reproduction. These are beneficial organisms out there, different faunas in different parts of the country. We're not advocating anybody sell and move them around for a variety of reasons, but these are naturally out there. Recognize that they're dependable. The pests, on the other hand, I want to spend more time developing. And again, my job here is to lay a foundation for then you to understand the more practical details that both Keith and Wes will follow me with. Again, a lot of different kinds of critters out there, and you can manage that detail by thinking of them as members of groups. And in this case, in the top row of this table, I've listed some features about what I call the winter parasites. Think of them as body parasites. They live on the animals. We have lice. We have mites of different kinds. And these all come from other cattle. The winter parasites are host-specific parasites. They don't come from the dog. They don't come from the horses. People don't get them from cattle other than transient infestations. Winter parasites. Think of them as a group, and you can manage them as a group. During the summer, we have a greater variety, and when I saw the title for this, I said my first job is to distinguish between the kinds of flies that we can do something about, on the one hand, from the kinds of flies that we can't do much about. And here I find it's useful to think about the aquatic biting flies, which are mosquitoes and horseflies and black flies and biting gnats. These are all blood-sucking insects that attack animals, and people. What makes them a group is that they all come out of wetlands. And in turn, if you think of swamps and streams and those sorts of places, it turns out that those are difficult to manage. Source reduction doesn't work very much. The best we can do for the aquatic biting flies is hide from them. Let our animals express their naturally defensive behaviors, perhaps allow them access to refuge. We can add traps and repellents to that. We'll be developing that idea later on in our workshop today. Finally, the bottom group, the filth flies, are things that we can do something about. We recognize that they're of economic harm, and they can be divisible into two groups. And Keith is going to talk about control of stable fly and house fly. What makes them important is that they come from debris where animals are penned. And in turn, we can use sanitation and debris management as a way of preventing those populations from getting to damaging levels. Basic idea in dairy pest management is source reduction. And it works for stable flies and house flies because we know where they come from. In contrast, the bottom two, face fly and horn fly, and I'll illustrate these in a moment, these all come only from cow dung pats. There's no other substrate that these insects develop in. A pile of horse droppings, I affectionately call those road apples, they do not produce horn flies or face flies, and so forth down the line of the other animals whose feces are out there. Those two flies are specific to cattle, and in turn, managing other substrates isn't going to affect those flies. It's an important thing to be able to distinguish where your enemies, or who your enemies are. The next step is where are they coming from, so then you can think about what sources can you manage to reduce their numbers. Let me develop this a little bit more. Let's talk about the winter complex first. There's 9 different species of lice and mites that we know occur on cattle in North America. They all tend to increase in numbers during the winter, and this shows up as animals standing around grooming themselves with their tongues or rubbing themselves against fences and so forth. You'll see signs of what we interpret as itching and hair loss and so forth, and these are external presentations of an infestation on the skin of the animal. There's some evidence that large numbers of these parasites, or really irritated animals, grow more slowly if they're beef cattle, or perhaps produce a little bit less milk if they're infested. What's interesting about them is that these all naturally disappear during the summer in the absence of treatment. They're there during the summer. They don't go extinct. We just don't see them because the disease has moderated. But come fall and winter, when the weather gets cold again, they come back up. Okay, so those of you who have a chronic problem here should be saying, what can I do in fall to perhaps eradicate these from my herd so that I'm not having a perennial return in subsequent years? We're not going to discuss that subject now. Perhaps that's a topic for another webinar later in fall to talk about how to deal with the winter complex of body parasites. Turn to summer, focus for today. Let's talk about those aquatic biting flies in particular. Many of you know these, probably dislike them, perhaps have fed them yourself, been attacked by horseflies. In our neck of the woods, we have a few mosquitoes. That's Minnesota understatement. Black flies, I hear, are actually more abundant up this part of the world. And then biting gnats in certain parts of the country are problematic. All of these have the common feature that the adults suck blood. In fact, it's just the females that suck blood. The males don't attack animals at all. What else unites them is that they all develop in wetlands of some kind. Horseflies develop in swamp mud for the most part. Mosquitoes require shallow, still water, not flowing. Black flies, on the other hand, require flowing water. And biting midges come from a variety of swampy kinds of habitats. In the Pacific Southwest, dairy lagoons seem to be a major source of one that's involved in spreading blue tongue. Other than that biting gnat, none of these transmit pathogens that are important to dairy cattle in North America. The picture is different elsewhere, but we're fortunate here. These are not vectors of cattle pathogens, but they are still nevertheless a nuisance. What's important about the aquatic biting flies is source reduction is not an option. Wetlands are preserved. There are a few things that we can do to intervene, prevent populations from these things developing. They're out in nature. They're very diverse. They're very predictable. That is, there will be a lot every summer. And we, as managers of animals, we need to think about how to get our animals through the summer and let them minimize the problems. This is an illustration for Bugs 101. An entomologist starts by saying, what is it? We try to put names on them so that then we know something about their biology. If it's an aquatic biting fly, we know it has 4 life stages in its life cycle, and this diagram shows that point. All arthropods begin life as an egg. And mosquitoes, their eggs are either in singletons or in little rafts. The females put them where they will later get wet. When they get wet, the larvae hatch, and they develop as feeding on algae and such in their aquatic habitat. When they mature, they turn into pupae, floating individuals. They don't feed, and eventually an adult mosquito comes out. Mosquitoes can do this in 7 to 10 days if it's warm enough. Right? All of the aquatic biting flies have counterpart life stages here. What they differ in is where the larvae occur, but they all are aquatic. And, again, different substrates, not a whole lot we can do about them. If you watch your animals in the summer, you'll often see this kind of behavior. We call it bunching. Animals lined up in a rosette pattern with their heads toward the center, tails on the outside. It's the reverse of what muskox do when they're attacked by large predators up in the tundra. It's a defensive posture. We think it's innate. And it seems to be stimulated by a wide variety of attacking insects. Biting flies are the most prominent of them. Okay? If animals are tied and tethered apart, they cannot develop or display this defensive behavior. On the other hand, if they're free-ranging, which is one really attractive feature, I think, of organic dairy management, you guys have the pasture requirement. I think it is a blessing. If you have grass that you can have cattle out on, it gives them a chance to express their behaviors. If you have some woods that they can get into, they will sometimes seek deep shade as a way of avoiding attack by biting insects. If you have a hilltop and animals can get to it and there's a little bit of a wind, animals will find the least threatening habitat and adjust their behavior accordingly. Watch your animals, and at least you'll be able to interpret what they're doing even if you can't intervene to improve their comfort. Give them options, let them express them. I'm afraid that's the main options we have for the summer biting flies, the aquatic ones. Again, Keith, I believe, will discuss the use of repellents and traps and develop a little bit more detail here. I'll, for the sake of time, move on here to the filth flies, which is the main group that I want to direct your attention to. Another life cycle slide. Again, what life stage does an arthropod begin life in? All together now. Egg. Egg somewhere. In the case of the filth flies, they place their eggs in places where their larvae are later going to succeed. These are sort of piles of organic matter of one kind or another. With the filth flies, the larvae are called maggots. They have pointy little heads and round abdomens at the end. We can tell some species apart from others just by looking at the posterior ends. Look at the little respiratory structures there. They're called spiracles. When they get to their mature size, they turn into a pupa. And then from that, inside, there's major reorganization to develop what become later wings and legs and functional mouthparts. This is equivalent to what monarch butterflies do. If you or your kids have ever raised monarch butterflies, the same thing, except we have a maggot instead of a caterpillar, and a pupa, or in a case is called a puparium, instead of the chrysalis, but it's exactly equivalent. The issue for the filth flies is, where do they lay their eggs? Where do these larvae develop? And can you do anything to prevent them from succeeding? And I'm arguing that there are things that you can do, things to be developed here. The divisions among those filth flies, I find it useful to think about where animals are confined, where we bring feed to them. We spill it if they don't. They urinate on it, rainfall, they defecate in it. It creates an organic milieu of stuff, affectionately called manure, although manure is used often to refer to the feces that the animals produce directly. Our organic people recognize that manure is decomposing organic matter. It's not just feces. We have green manure. We have a variety of sources that make for that decomposing organic matter. Where we confine animals and bring feed to them, we create a habitat that is suitable for two of those filth flies, face flies, or house flies, and stable flies. Those are manageable substrates. We create them, we can dispose of them. And that's kind of the key to preventing those flies from developing. On the other hand, if you look out on the pasture where the animals are walking freely, their deposits of dung are intact dung pats. And from a bug's eye view, they are very different than the material that accumulates where animals are fed and penned. And again, from a bug's eye view, those dung pats are where face flies and horn flies develop. And in turn, all the barnyard sanitation in the world is not going to control horn flies or face flies, because that's not where they're developing, to be developed here. So, a little more details about stable fly and house fly. Again, they're coming from accumulated organic matter, largely a result of us penning or tending to our animals in confined areas. Stable fly. You're going to see a reference to these insects repeatedly during our workshop today, for the simple reason that these are everywhere. During the summer, they're really numerous, and we have strong evidence that they reduce the lactation rate of dairy cows and the growth rate of replacement stock, as well as the beef side of the industry. And I presume there are a few eavesdroppers from beef producers who are listening here. Of course, all dairy producers are beef producers too, right? Where do the bull calves go? So the same concepts apply here. Biting flies in dorsal view, if you look at them, you'll see a head, thorax, an abdomen, and wings with a characteristic angle to them, going out like this. Notice on the abdomen, there's a pattern of 7 black spots against a gray background. But most important, if you look at the head, there's this bayonet-like proboscis projecting forward from underneath their face. And there's no other insect around livestock in North America that have the combination of the bayonet mouthparts and the speckled abdomen. Okay? These insects are bloodsuckers. Both males and females bite. and they really love animals' legs for some reason. They'll bite animals in other body parts too, but if animals you see standing around stomping, that's a pretty good indicator that they're being attacked by stable flies. And you can look around the animals. As to the right here, you'll see I have a photograph of a blood-engorged stable fly. These females tank up on blood, and then they fly away from the host animal and sit and spend the rest of the day digesting that blood. You'll see fly specks, little bloody specks from where these insects have been perching. It's very easy to distinguish stable fly from any other cause of fly irritation during the summer. And in turn, if you know it's stable fly is a problem, now you can start looking for the sources of those flies. Tune your dairy management program to solve that problem. We use, as an aside, we use a measure of fly abundance called a leg count. Okay, every cow has 4. We know that. Why do you have to go count them? No, what we're referring to is a count of the flies that are visible on the 2 visible faces of the front legs. We call these leg counts. And quick, can you guys see? Probably not. We're having trouble with a lot of excess light in this room, and the images are a little small. You webinar people are probably seeing better what there is here. If you follow that red arrow, you can see 1, 2, 3, 4, 5, 6, 7 stable flies on that leg. Well, that's encouraging. Thank you very much. Okay, so 7 plus 0 divided by 2. Actually, we would call this a leg count of 7. The reason I bring this up is it's a quick and easy way for you to measure how many stable flies are bothering your animals. Almost as easy as just watching the animals. If they're standing around in that bunching pattern, you can be pretty sure that stable fly is involved, especially around a confinement facility. You don't have to bother with counting flies, but you can do some economics if you have a measure of fly abundance, an idea that I'll develop in the second year. These data are the best that we have. Any Jersey producers or managers here? Any of you have Jersey cows? Back in Illinois in the late 50s, there were a pair of authors, Bruce and Decker, who published a paper which to this day are the best data we have on the effects of stable flies on lactating cattle. 1958 is kind of close to my age, so I can stand up and proudly say getting old isn't necessarily bad. Old data actually weather better than I and probably the rest of us who are aging. Okay? What's this show? This is showing on the vertical axis a measure of reduction in milk production per cow per day. It's in kilograms, so multiply by 2 for a rough conversion to pounds. The x-axis is showing a measure of fly abundance as a leg count, the average number of flies per front leg. These dots, each one represent either a whole herd of cows on a separate farm or a sub-herd of cows on the same farm, half of which were treated with repellents that would not pass national standards today for organics. Okay, but nevertheless, it created a range in fly numbers, and what we can see is that as the number of flies per leg increased, so did the reduction in milk output. And a quick way to think about it is as a percentage reduction, which is what is on the matching X or vertical axis. And their worst of conditions, they were documenting a 30% reduction in milk production per day if there were up on the order of 15 flies per leg. Now, I think that's serious change. And whether or not dairy cows today, Jerseys in particular, or the taller Holsteins or what have you, as those breeds change, we have to interpret these numbers cautiously, but I'm pretty certain that if there are decent numbers of stable flies, meaning 5 to 15 flies per leg, that the animals are suffering, the milk tank is not filling as fast per day, and the milk check getting lower. So the rationale would be to think about how much can I afford to invest to prevent those losses? Is it going to pay for itself? And that's a fundamental economic decision that I'd encourage you all to try to make. There was a question here.
Does it matter front leg versus back leg?
We've adopted a front leg. He asked, does it matter front leg versus back leg? In fact, Keith and the dairy people in New York count flies on all 4 legs of replacement calves in some of their growing facilities. I don't think it makes a whole lot of difference. Front legs are sort of standard, and often my experience is as I come to cattle, especially if I'm shaking the grain bucket, they're going to turn and come walking to me, and in turn I can get a good shot at their front legs and do a quick assessment in 5-10 minutes. I know how many flies roughly are on those animals. I'd worry more about when it's cold versus when it's hot than I would worry about whether the animals are facing me or I just happen to get lucky and get some hind legs as they're running the other way. That's a good question. Thank you for asking it. Okay. The other confinement breeding fly is housefly. Now this has a whole different set of knives, forks, and spoons. Notice that the abdomen is striped. It's not speckled. Notice that that bayonet is missing. And in side view here, the mouth parts actually have a big fleshy tip. They cannot bite. They can at best come up and give you a big kiss. They open up the ends of their mouth parts. They will often regurgitate. And their job is to feed on fluids or make fluids by vomiting on it. They cannot bite. And flies don't gain mouth parts or lose them during the course of their lifespan. They're born with what they have. So the weather's changing, the flies are starting to bite. It's not because the house flies got hungry. It's because stable flies moved in. And it's a common misconception. Oh, and as an aside, once flies reach adulthood, they don't get bigger. You don't have baby flies growing up into larger flies. Their size is stuck at the time that they emerge from their puparium. And that's an important distinction. If you see variation in the sizes of flies, it's largely because you have different species of flies there. And again, know your enemy. Be able to distinguish among them. Quick survey around dairies about where these confinement breeding flies come from. This is at the end of a feed bunk. Look where feed is spilled. Gets wet, starts to decompose. Really critical. It's easy to find maggots, and if you want to get out during the summer, trowel is useful. You can make do with a stick. Gloves are optional. Boots are optional. All right? But you're looking, these things are photophobic. They don't want to sit out in the sun. They want to burrow down under the surfaces. So you need to go in after them. Don't go down to, if you hit clay or you hit dry soil, they're going to be in that moist habitat that's on the surface. And a scout, to look for these things, would run around and just break the surface off, sort of shaving the top off the piles. And if there are larvae there, you'll see them. They're moving. They're really easy to see. Look where feed is spilled and accumulates. Look where calves are penned. There's good evidence that calf pens are quantitatively the major source of both stable flies and house flies on dairies. That was work that was done at Cornell, and it's been done here in the New England states, as far down as Maryland, too. It's been established nationally. We know that really well. If you pile organic or pen debris, that just concentrates it into one place. Piles are deadly. If you get rainfall coming, the moisture conditions will get right. I refer to maggot heaven. And what I'm talking about is the right level of moisture and aerobic habitat. These maggots are not aquatic. They'll drown if you get them totally wet, and they need moisture for their bacteria to grow. It's in between. It can't be too hot. It can't be too cold. All of that compromise is what I call maggot heaven. And as managers, you want to minimize the supply of that. Piled manure is a prominent place to look for maggot heaven on your place. Finally, lagoons. A lot of dairies pump material or scrape it off into lagoons. Standing water, you may see a little bit of breeding around the edges of the lagoon, but generally, if it's well managed without anything on the surface, it will not be a producer of flies. On the other hand, if it has big floaters and a big mat, then you get dry to wet. Somewhere in there will be maggot heaven. And I'm just trying to sketch out possible places where these flies can be breeding. No two places are the same, so an important issue is to scout, a point I'll make. We had a question on the floor here a moment ago.
How about bedded pack?
Bedded pack. Let me come to that one. Good for you. In that habitat are a bunch of beneficial organisms. These are predators. They eat fly eggs. They eat fly larvae. We want to conserve these arthropods. We have a predaceous beetle here. This is actually a predaceous mite, and this is actually a predaceous bug. And there's a rich complex of beneficial generalist predators that occur in the fly sorts of habitats. If you can keep the substrate dry and spread out, these guys do better, and they will actually kill a greater percentage of the eggs and larvae that could otherwise develop. On the other hand, if it's a relatively moist substrate, the success of the flies is greater. The predators don't make it Basically, if you can get this thing spread or kept very dry, these predators will help you more than otherwise. There is another whole class of beneficial insects that some are illustrated in posters in the back of the room, and we have many handouts for you to take that give you more details about these, including a printed handout of my discussion today and all of our discussions. The woman in the hotel this morning said, beneficial wasps? They can't be. They all sting me. Right? She's thinking of yellow jackets, and the public thinks about hornets and yellow jackets and bumblebees when we say the word wasp. So we tack the word stingless on the front to sort of make them sound innocuous. The real entomologists know that that's dead wrong, because these insects actually do sting, but what they sting are the fly pupae in their habitat. These insects make a living as parasites. Again, here's our life cycle: egg, maggot, pupa, and adult. This is a little wasp. You can see how large the pupa is. It's on the size of a grain of rice. So this is a little tiny gnat. Think of it that way. And I've heard someone refer to them as smart bombs. But you release them, let them go, or naturally they come out. They search the habitat, finding the pupae, and in turn they sting, develop inside. Now these other images here are with the case removed, the puparium removed, and it's showing the grub of the wasp that was developing as a parasite on the fly inside. Finally, it pupates, and instead of getting a fly out, which is a bad thing, we get a parasite out, which is a good thing, a stingless wasp. And these guys are out there naturally. You can also purchase them from commercial sources with the intent of augmenting what's naturally occurring on your farm. We don't have a simple way to judge whether you need them or not. I would say if you have too many flies, there's a possibility. Start with sanitation and then proceed according to what you find there. I talked about scouting just a sec. Again, trowel is useful, gloves are optional. Scrape through possible sources of flies. Think of accumulated organic debris of all kinds, and look for action. Larvae, again, are going to move away, and here are images of actually one species of fly. This is stable fly. This is that posterior end, those little spiracles. This is not a smiley face. These are not eyes looking back at you. This is the other end. And there's no other insect in that habitat that has this sort of appearance, with two little dots farther apart than their widths. Tapered, and you'll find pupae in there too. Look for these. If you find them in any substrate, said, how can I prevent that from recurring in the future? How can I prevent it from occurring in the first place? And in turn, you can adjust your management. There was a question over here in front. Ma'am?
Oh, I was just wondering how you identify the stingless wasps that things that happen while
in short, the way we do it is we take pupae out of their substrate, we isolate them, and we raise them out, and instead of getting a fly coming out, we see this smaller insect. The web people won't be able to see this, but in the back of the room here we have some examples. Beyond that, it's going to take a microscope or eyes much better than mine, and I suspect yours too. Okay, Wes?
Robbie might add, you can see the exit hole.
Yes. With a scope, you can actually see the little hole that the wasp chewed out, which will show you that somewhere back there somebody did you a favor. That is, that fly didn't turn into a fly, a parasite came out of it. Good. Thank you, Wes. Okay? Things you can do. Every facility has different equipment, different problems. Generally, if you can scrape and haul feces or soil bedding and spread it out frequently, once a week is sufficient, you can prevent flies from building up in those substrates. If, on the other hand, composting is an option for you, I'm kind of an advocate for composting because once it's composted, it's no longer suitable for fly production, ever, period. And enterprising people can sell that stuff to local gardeners. Maybe composting is a way of reducing the liability of what otherwise would be piled debris. So there's an option. If it's just a cold stack compost pile, that ain't going to do it. You've got to turn it probably once a week, if not more frequently, and get it up above about 140 degrees Fahrenheit. Gloves optional, plunge your hand into that pile, and if you don't pull it back because it's hot, it's probably not hot enough to be killing and preventing fly development from happening in it. So active composting is a good thing to do. The question from this fellow here, your name is Brian? Yes, Brian, about a bedding pack. This design is taking over in Minnesota. It actually started in Virginia. We call it sawdust compost bedding pack barns. And the idea is that the animals loaf in these barns. Now this is during the winter. They come in and top dress with dry sawdust mainly, or other materials, till it, and get it to actually compost itself. Come spring, when otherwise the bedding pack would thaw, come spring, this material is not a productive source of flies. This is a good thing. During the summer, organic people, the pasture requirement, or requirement, yeah, those animals aren't spending time on these bedding packs unless you're holding them in overnight, right? So this really is an option for preventing the summer fly breeding, but you're not dealing with the confinement breeders during summer. The problem there is out in those dung paths. So there's places for composting here. Got it. Thank you. But again, scout your place, look for other sources too. Very important. Calf hutches. Okay, if we can get you to move away from straw, we're going to win half our battle. Turns out that straw as a substrate for calf hutches, or for that matter, bedding packs of cows, is, for some reason, a really suitable place for developing house flies and stable flies. And on the other hand, if you use wood chips, or corn cobs, ground corn cobs, or sawdust, or sand, any of those things, for the same amount of animal inputs, we get many fewer flies from the bedding materials. So again, straw is, we understand it's available, it's cheap, especially if you're growing your small grains. It has a cost, and the cost is it produces stable flies, which can reduce the productivity of your animals. Kind of the bottom line. Think about the feed end of your enterprise. Where's feed stored? How's it presented? Scout there to see where active breeding is going on. Keep it dry, spread it, compost it. There's a variety of options to prevent it from producing flies, but however works for your place, do so. Same with bedding. We can move you away from straw. With the same idea, get it on the dry end. Your beneficials will help you more, and you'll produce fewer flies. And finally, the manure itself, perhaps around the milking parlor, get it out of just piling it out the back door is a recipe, certainly for housefly blow-ups. See if you can do something to modify the habitat there. I'm told I have about 7 minutes here, and I think I'm timing this about right. Let's go outside the confinement area and think about the pasture end of your operation, which is the main summer issue. Know your enemies again. We have face flies, which are insects which mostly occur up on the heads of animals. They're visiting for a sip of liquid materials of some kind. On the backs of the animals, the textbooks say, you'll see horn flies. These are smaller insects. And then if the animals are close enough to a confinement facility or some place where feed has been brought, you can see stable flies out on pastures. That's what the textbook says. The face fly part's right, horn fly part's not completely, depending on where you live in the country. What makes these two insects important, face fly and horn fly, is that they only come from dung paths, a point I made a moment ago. And of the two, face fly is visible. We think animals are irritated, but we don't have any evidence that affects the productivity of the cows. And we have pretty weak evidence that they're involved in the transmission of the bacteria that cause pink eye. Couple that with we don't really have any good ways to control face flies. My advice is this is a battle you shouldn't take on. Don't worry about face flies. Focus, on the other hand, on horn flies, because we have strong evidence that they reduce milk output, and we have some options for controlling them. So this is my bumper sticker, aim for horn fly by the 4th of July, which is tuned for Minnesota for a reason I'll show you in a moment. Elsewhere in the country, that could be March 3rd or Labor Day or, yeah, you pick your holiday. I won't go as far as Christmas, but face flies are really conspicuous. These are on beef cattle, my apologies, but they occur on dairy cows. Doesn't make any difference what breed. They're more visible on white-faced animals and easier to photograph. This is a pretty far along case of pink eye. And when facefly first appeared in North America, about 1955 through 1990, depending on where you were in the state or in the country, pink eye seemed to be more conspicuous. But if you talk to the old producers in any audience, and there are a few that were in the business before 1960, ask them if they had pink eye. The answer is, yeah, we had it. Well, that tells you that facefly isn't essential because facefly was introduced. They had pink eye before. The logic then goes, maybe we don't need to control facefly. We will still have pink eye. What we should be doing is treating the animals to prevent the disease from progressing to the point as is illustrated here. Hornfly, on the other hand, again, this is the top of a bull actually in Uruguay. These are small little insects. They're actually closely related to stable flies. They essentially ride on their host animals as adults. Wherever they emerge, they get on the cattle and they live the rest of their life there. And we have good data that says if you have decent numbers of them, controlling them some way is going to improve productivity of the animals. I used to say, or the textbooks say, hornflies reside up on the backs of cows, until I went down to North Carolina last May and saw lots of examples where it's hot and humid, hornflies cluster down on the belly. And you milkers, these flies will ride the animals through the milk parlor. You see them down on the umbilicus, right? You can see them on the milk vein. They're down there. Look up on the top, you'll see a few riding there too. So if location isn't everything, but if you look at the size of the insects, if there's any insect sort of in a cloud and they rest with their heads pointing downward, and these are smaller insects, you can even see them on the legs. These are all sitting here with their heads downward, with a few exceptions of stable flies, which rest with their heads pointing up. So a combo of size and posture is enough to at least inform you of the differences between those two kinds of insects. Face flies and horn flies grow in cowpats. The point I made earlier, it takes about 2 weeks from where the flies lay their eggs. During the day of birth, I call it, deposition, drop, there's no fizz. But the flies orient to those dung pats, lay their eggs, and then about 2 weeks later we get adults out of them, more or less, okay? These flies are not coming from barnyard substrates. So all the barnyard sanitation in the world is not going to affect the abundance of horn flies. We've got to do something else. Do you have a problem? Don't know. Watch your animals. If you see them bunching up like these heifers are, one possible cause is horn flies. Don't rule out the aquatic biters. You need to go look for the insects. But if you can see decent numbers of horn flies on your animals, then that suggests you might change your management to get to reduce those numbers. Here's the pattern in Minnesota that we've seen over a bunch of years, going back in the 80s and 90s, at our what is now our organic research dairy in Morris, Minnesota. And you can see we count flies on the sides of animals, rough numbers, but you can see they start in early May and they putter along in July, and in August the populations build, and then they natural collapse in September and early October. So my advice is to try to get some sort of hornfly control program in place by the 4th of July with the intent of preventing this later buildup. Okay? Don't try to knock down the adult flies, but prevent the population from building to the point where the animals are predictably annoyed. Here are the data that say you control flies somehow that has reduced the numbers compared to matching infested controls. You'll boost productivity by about 5%. There's variation. Each one of these points represents a pair of herds, and this is showing the percentage production relative to the infested counterpart herd. It doesn't depend on how many horn flies were on the infested animals. It really doesn't depend on the percentage control achieved within reason. On average, you'll get about a 5% boost in production from whatever control method you use. This is what the data say. I ran some numbers here to show you what that might amount to. I don't know what you guys are getting for milk this year. Organic prices, conventional are about $15 a hundredweight. What's the dairy rates going here for organic milk?
Say 30, 32.
30, 32. Okay, good. This is showing per 100 cows, if you prefer to think of it per cow, move the decimal place over 2 points, per 100 cows, what the daily reduction 5% amounts to, depending on what your milk price is. This fellow over here says 32. Well, that's a little bit beyond my 30 column here. But if you were, and how much are your animals naturally producing? What's their daily production? 30 pounds a day, 40, 50, somewhere in there maybe? Maybe we don't want to talk about that publicly. Fair enough. You know your number. You can look up here and find in this table a rough feeling for how much 5% reduction or 5% loss amounts to, and judge whether what you're proposing to do will solve the problem. I've got to get to a couple of quickies here. She's giving me the red flag back there. Yeah. Yeah, she is. I'm not colorblind, but I act like it. I thought that was a red flag. Okay. Let's think about the pasture operation. Where are hornflies coming from? It's the dung pats out on pasture. Okay, sanitation isn't going to work. We don't have the time and the labor to go out and pick up the feces fast enough to keep up with the hornfly population. But there are some options. Sticky traps are among them. You could place them along the lanes, perhaps, where the cows come and go, and you will catch some flies. Unfortunately, few of them are hornflies. If you're going after hornflies, sticky traps really aren't an option. They're also a problem because you put them up, you go, oh, holy buckets, look at all these flies. And a week later, the traps are all congested with flies and dust, and your chores are pulling you off somewhere else. Traps require maintenance. Freshen the goo, clean them up. And if you want to go that way, just realize that you have to keep up with them. And we don't have any evidence that we can keep up with the hornfly population with sticky traps, either outdoors or, for that matter, in the milk parlor. We do have evidence, and we're going to talk about this more in the rest of this workshop, that what's historically called a Bruce walk-through fly trap will dependably reduce the numbers of hornflies on pastured cattle. And what we're seeing here is this box with what looks like fly screen on the outside. The fellow on the four-wheeler on the back is bringing in the animals, probably coming in for milking. And the animals are going through this thing much like cars would line up and go through a car wash. The interesting feature about this trap is that it makes use of the fact that the cows will come in, the flies get dislodged, they get stuck in the sides, and it removes some percentage of the flies from the cattle as they're going through. And this is sort of an entrance view. These are chunks of carpet or who knows what is available, probably burlap sacks, in about 2 feet from the entrance of the trap. And the animals go in that dark area. The hangers dislodge the flies. They go out to the sides, which are lit here, and the flies work their way through baffles, and they get stuck in the side. They can't get back on the animals, and they die of starvation. Yay! Okay. If the cows are going to the milk barn twice a day, I would prefer to see these on the entrance to the milk barn. But either way, twice a day through a trap pulls off some flies each time, and we're thinking that with repeated use, we can keep ahead of what would otherwise be a growing hornfly population. Just a second. We want these in places where cattle are forced to use them. Now, dairy is a natural option for the milk cows. What about the replacement stock? What about the dry cows? So if you can, as this one is showing, there's a source of water off here to the right. This one is in the middle of a fenced area, so the cattle to get to water have to come through it. And it's not a directional trap. They can go either way, in and out. And so, again, every place is different. Where's mineral provided? Where's supplement provided? Where's salt provided? Where's water available? See if you can put a trap. If you want to try one of these traps, see if you can place it where animals, the larger the percentage, go through it every day, the greater the level of control. There are, and this is my closing point here, there are PDFs, that is, stored files of plans for producing these things. North Dakota State has produced a set. University of Missouri has a set online. University of Arkansas has a set online. If you want them, I'll send you all three of them together, bundled. Send me an email, rdmoon@umn.edu, and I'll get them in your hands. Take-home points. Who are your enemies that are important? Stable flies should be one of them. And in turn, the solution, the strategy is to prevent the numbers from getting large around your animals, and to do that through debris management. we think the profitability of that is going to be pretty high. So that's one point to take home. And the other is equivalent for hornfly, but that sanitation isn't going to do it. Walk-through traps or hornfly traps of some kind seem to be an interesting avenue, certainly available to organic operations. And the evidence we have says it's likely to be a profitable thing to do. Those are the points I wanted to get through. I'll invite questions you have or any comments you would like to make. There's one here in the audience.
Do you have any suggestions or experience on how to get cows to walk through those?
The question is, do cows naturally want to walk through this fly wash? The answer is, the experience we've had collectively is that it takes a little bit of training, but not much. I've made the comment that I want to see a Chianina herd trained to do this. That would be the real test. But working with Jerseys for sure, Herefords, Holsteins, even Charolais. There's lots of examples where people, and start slow. You might start by just putting up the fence and get them used to the idea of going through the fence, and then bring the sides in and slowly creep to the point. It's not that hard to do. Yes, the webinar question?
And so maybe if you could repeat the question too. So why not sell dung beetles like you might get wasps?
Why not sell dung beetles? Well, so far nobody is selling them. I can think of several of my own reasons why. They can be reared in mass. In fact, as a graduate student in California, I was mass rearing them to plant them in the state to try to get different species established. But the obvious problem is biosecurity. These dung beetles need to grow up in dung, and it would require a biosecure source of cow dung to produce beetles that would safely be transported over the country. Who knows what sorts of microbes and parasites would be spread in those beetles? And generally, I favor local and stay local, and is not transport things wildly all over. From a biosecurity standpoint, I think that's the reason why we should not be doing that. But I'm open to counter-arguments. Fellow across there? Yes. That's a good question. There are naturally occurring parasites of hornflies, but they're out there in that pasture habitat. There are some that are abundant. They are not the ones that are being marketed, to my knowledge, at this point in time. That would be my prediction, yes. Same with face flies. Different habitat, and the parasites that we naturally see in those habitats are not the same species as the ones that are being marketed for confinement, specifically to control houseflies and stable flies. Different habitat, different kinds of parasites. That's what our research is showing.
We have another webinar.
Another web question? Good.
So would breaking up the paths in your pastures have any impact on fly population?
Would working up the path, say disking or chain dragging, you're going to have to do it about every other day. And I would ask you to, when you calculate the cost of the control, figure out the cost of the diesel or the gasoline if you're running a four-wheeler. My sense is it probably won't pay for itself.
And what about free-ranging hens or poultry on the property? Would that cause more problems than they solve?
I think free-ranging hens are moving in a good direction, but we don't have any evidence that it'll keep a lid on hornfly or facefly populations. I don't think they'll hurt. They might taste good. The eggs might be a useful revenue. The fact is the chickens eat a lot of grain, right? And so they're generalist grazers, and they're not homing in on hornflies or faceflies. So I think there would be more profitable options to try first. One last question here. Am I out of time?
Yeah.
Okay.
Just a quick question about the predators of the maggots. Any information about conserving the predators to get them to be effectively controlled in those dung pats in the field?
We're just predators in dung pats in the field.
Yeah.
There is, in fact, some studies, mainly coming out of Missouri. I'm looking to my colleagues to see if they can remember. I think it was Rob Hall's graduate student studied predators in dung pats. We know that they're there. We know that they're probably killing 80 to 90% of the eggs, preventing them from turning into adults. At this point, I don't know of anyone that's proposed that we manipulate them somehow to make them more effective. It's pretty much a pristine habitat, and it's inaccessible from a management standpoint, right? So just, clap your hands and say thank you, nature, for producing those beneficials. I thank you all. You've been a very, very attentive audience, and I appreciate the questions that you've asked. We have materials and posters and display materials, those in the web. We'll look for a summary of your questions, the ones that we haven't had time to answer, and I'll get out of here so we can move on with the rest of the workshop. Thank you very much.
So, thank you very much, Dr. Moon, and that was really fascinating. Every time I see a little tiny fly, I think it's a baby, so now, no, that's not true anymore, thank you. And then what about those big fat flies that fly around in your house in the winter that are really dopey? What kind of flies are those? Oh.
They're probably cluster
flies. Okay, well, this is really great information, and Earl's been having me sprinkle little parasites and maggots around our farm trying to get rid of horn flies. I guess we don't have to do that anymore. All right, so just so everybody knows in the audience here, we do have a question and answer session this afternoon after lunch, and so if we don't have time to get to your questions, write them down, and that way after lunch you'll have time with the speakers. It's a real great opportunity to have them all here in one room, so hopefully we can take advantage of that. And our next speaker today is Keith Waldron from Cornell University. I have this great introduction for Keith. He's a Cornell University Senior Extension Associate who serves as the Livestock and Field Crop IPM Coordinator with the New York State Integrated Pest Management Program. And I've known Keith for a little while now, and I think he's just an excellent resource in this area, and he's fairly close by to us, so even better. So thanks, Keith, and let you go from there.
Thanks, Heather, and thank you, everyone, for joining us here this morning for a discussion on flies, some of our favorite topics. I wanted to continue to build upon some of what Roger has presented for us, and I will get familiar with what our machines require from me. There we are. Oops. Come on. Can I do that? Okay. So from building upon what Roger presented, I think we're beginning to kind of get reacquainted with there's a number of different flies that can affect our animals out on pasture and in confinement. For the dairy community, some of those key players are things like the house flies, stable flies, face flies, and such as you see here in this list, going on down to the winter active parasites, cattle lice, and mange mites. It's important as one of the first steps that we would think about to understand the correct identification, and Roger did spend a fair amount of time on that, because certain flies are going to be more likely to be found. I'm sorry about this. Come on. Deb, I'm going to need your help on this again. You can tell that a Macintosh person is operating the machine here. Certain types of flies are going to be found on a pasture, horn flies and face flies being two of those. The ones that I'm going to concentrate are going to be the ones we're going to most likely find in confinement areas. Those are going to be house flies and stable flies during the summer months. We're also seeing more, as time goes on, of horn flies coming into the barns, as Roger mentioned, riding on the animals into the barn. What I like to talk about, I guess, is we'll think about four common areas. Livestock pests, we've already talked a little bit about the potential economic damage that these insects can cause. One of the other things, even organic people will need to consider is if you're looking at ultimately managing them and you've tried everything and nothing works, what are the resources you have? Well, from a chemical standpoint, we have pyrethrins. For conventional farmers, they have a number of other options. There's been documentation of a lot of insecticide resistance to things such as houseflies not being able to be controlled with chemicals. One of the things that we need to think about is how to look at an integrated approach to managing these that doesn't require insecticides, but can look at some of the things such as sanitation and cultural practices. One of the other issues is these flies move around a lot. A number of our farms are close to urban centers or to towns and such, and off-fly immigration is an issue. We've been involved with a number of situations where the neighboring farm, new community, lots of nice fancy houses and such, flies are coming into their neighborhood from some source. Is it from a dairy farm? Is it from some other location? We get called in to look at mitigation issues. Another thing that is potentially involved here is transmission of diseases. We mentioned pink eye. We're also looking at blood removal, feed conversion efficiency, ultimately the types of things that these arthropods will do to affect economic impacts on the farm. There are fewer and fewer materials available to us. We need to manage them wisely. The principal flies that I'll talk about then are going to be house flies and stable flies. We're going to talk about their biology, kind of building upon what Roger's talked about, fine-tuning the fly management around the barn and confinement areas, and then resources that we have available to us. So let's talk about this integrated approach. And the slide that I have here is a situation that I see more and more in the Northeast, at least in New York, calf coveralls. As Roger's mentioned, and I'll dwell upon this a little bit, if I had 5 minutes to spend on a farm looking for a fly issue, I'm going to look for the calf areas, and we'll get into some of those reasons why. Some of the things that we might think about, and I like to think about this in a series of steps. The first step that we want to know about any of these fly issues is know your enemy. We've already said that. What does it look like? What is a good guy? What doesn't really have any impact upon us? And what are the really ones to key in on? So we'll build upon biology and habitat. Where do you find these things? What are the conditions that help them to increase in their populations and ultimately cause us some havoc? And then how do you monitor them? And we had a little bit of discussion about looking at numbers. That gives us a relative idea about populations, realizing that a certain number of insects are going to be required before they're actually going to cause some economic damage to the animals. Animal comfort is going to be an issue. Some of these things are going to be part of our discussion about farm-by-farm types of thresholds that you might develop, but we'll give you some guidance there. And then I'll talk about some of the control tactics that we have available to us, continuing our discussion. Ultimately, all of the things that we talk about, you can test them on your own farm. You can try them out. There's going to be a little bit of art, a little bit of science. You're going to have to take notes and be attentive to what's going on and evaluate. How well did things work? What didn't work so well? What worked fine? What do I need to think about or improve or look for additional answers down the road? Roger's talked about the identification of our two key species. Everybody can remember the housefly does not have a biting mouth part. It has that flat front on its face. It's got stripes on its back. By contrast, the stable fly that we see here, I like the 7 spots on the back and the biting mouth part in the front. Very distinctive. This is a little bit of a family diagram here. We have the egg stage, late instar larval stage, the brown egg, let's see if I can get the arrow over here. These pill-looking things are the pupal stage. Right after that, we'll have the adult flies emerging. Two things that I'd like you to look at here is the life cycle of these. The housefly is going to have a little bit quicker development time than stable fly, and we'll see how that plays into potential management. And it doesn't really matter so much how many eggs are produced, but it does give you an idea about potential population buildup over time. And they both will live someplace around a week to 3 weeks or so, depending upon how close you are with the fly swatter. Houseflies, one thing, it's a primary pest. We see this on virtually every livestock operation. It is going to be a factor in transmission or potential transmission of diseases such as mastitis, E. coli, salmonella, and such, so it is one that we want to think about. We do have very high levels of pesticide resistance to it and rapid development rates. And I'll show you a diagram of what it could theoretically do over the course of a very short, warm growing season. By contrast, these stable flies, as Rogers mentioned, the biting mouth part in the front, these are 2 electron micrographs of that particular area. You can see it's actually movable, and if you sit and watch these things as they're on your arm or on your leg, the mouth part will move around, kind of like a snake. And at the very end, the head end of it, you can see that there's some really nice biting materials here, some really nice chompers. So these are blood-feeding insects. They're going to be annoying and biting and causing serious havoc to the animals. Blood fighting, and this is painful. If you've gotten bit around your legs when you're working around the animals, it's been a stable fly. It can develop on and off farm, and I'll show you some potential areas that I would be looking for the flies to be developing. And as Rogers mentioned, reduced growth of our animals and milk production. So you can see a picture of a number of flies on a calf leg here. There's quite a few of them. Sometimes when you have this high number, you can also notice that on those areas the animals are stomping their legs to try and dislodge the flies. But you can also see some animals will have like an allergic reaction. Well, they'll actually lose hair in that area. And that hair loss might be the size of a dime or smaller. But under those conditions, your animals are just not happy. And if you're working around the animals, it's not only you, but it can also be that those sources of flies are also hitting you around your ankles, lower leg parts. Some information to kind of talk about development. And a key thing about fly development is these are cold-blooded animals. The cooler they are, the slower it's going to take them to develop. The warmer they are, the faster they're going to develop. Now, for dairy farmers that are also growing field crops, the nice thing is under the cooler conditions, which would be hopefully the usual spring, it gives you time to be doing your field work. And monitoring and managing these fly habitats, you have a little bit more time to before the insects go from egg to adults and begin to build up their fly populations, slower populations or slower development. So you see at 68 degrees, it's going to take them about almost 3 weeks or so to develop, to go from egg to an adult. But as we get warmer, we get into the 77, 86 degrees, which this spring we have had in some situations, a lot quicker turnaround. So you need to think about one of the management things is going to be breaking up their habitat and removing them before they have a chance to fully succeed to go from eggs to an adult. Here's a graph here. If we think about that housefly producing 600 eggs or so, and every one of those eggs was viable. Of course, that's not going to happen, but this just gives us an idea that if you had that one fertile fly around June 1st, you could have significant population growth over time. So we want to see what are other places that are the weak links in the development that we can stop and head off before they are allowed to continue this population growth. As I mentioned, if I had just 5 minutes, 10 minutes, whatever, a limited amount of time to go out on a farm and visit and look for fly problems, first place I'm going to go is going to be in the calf area. And one of the key reasons is the animals that we're talking about, what type of bedding are they on, and we'll get into that in a second. Are they sloppy when they're eating so that you have conditions with moist organic matter? You've got moist bedding. You've got spilled feed. You've got a calf that might be over-exuberant, so she's spilling water all over stuff. And you have the type of conditions that have that moist organic matter, and they also are not going to be changing the bedding on a daily basis. So spilled feed, bedding, and such. And the other issue is the smaller animals, if they're walking around in their pens or on that bedding, they don't have the weight to crush developing eggs or developing larvae. So in corners are places where the animals are not stepping. You have potential areas where the flies are going to have the potential to reach maturity. So we'll look at calf hutches. Other areas to think about: moist organic matter, could be silos, leaks and spill areas, animal stalls, pens, under feed bunks, storage or feed preparation areas, water sources, and then calf and maternity areas, hospital areas, water tanks, feed troughs, and manure handling areas. I think one of the key things that Roger mentioned too was these insects are kind of like Goldilocks. They want to have the right amount of moisture. If it's too dry, they're not going to develop so well. And if it's too wet, they're not going to develop so well. So they want it someplace in between. And if you've got a really soupy situation, which you can find around these silos, and you're noticing a lot of activity, and there's actually maggots swimming in those there, those are not houseflies or stable flies. Those are going to be rat tail maggots. They are not going to be harmful to the animals. Their situation is they're there because it is so moist and putrid kind of organically water situations. Their challenge is looking ultimately for a place to pupate, and they might migrate in mass, and when they do, the challenge could be to keep them out of the milk house, which is pretty easy to do. But they're not going to be the flies that we're really concerned about, these house flies and stable flies. Some pictures that we might be looking for potential habitat for flies. I'd be looking underneath the water buckets. Nice thing here in this cat pen is the water buckets and feed buckets are outside the pen. An area that could be, that could be cleaned out pretty easily. I'd be also looking in corners where the animals cannot stand and crush the developing fly larvae that might be there. In these type of water situations, on the upper right-hand corner here, you have a nice waterer next to some standard feed bunks. The areas that are in between the water and the feed bunk are places where things can accumulate, organic matter can sit. I'd want to clean those out daily if possible and keep the things dry, because that would ultimately be good habitat for fly development. Down here in the calf hutch in the center photo, you see this has got a lot of straw. It looks like it's been freshly added to over time. They'd have the water outside this area, but I'd be looking around the corners, trying to find my arrow here. I've lost it. Here it is. The corners around the threshold, the corners in the back, areas where the animal cannot stand close is an area that the fly maggots can get to be older and then ultimately survive and then lay more eggs. Some additional breeding sites, if we're talking about an inside stanchion area, around the edges of the pen, places again where the animals are not being able to stand, close to where water is, areas that are maybe have some seepage in from outside. These are places that I'd look for that moist organic matter. Corners, some of the areas such as around the corners of a concrete area. As Roger mentioned, take a trowel, scrape off the top here. You might be able to see here, there's a lot of kind of dark brown and light colors. These are fly pupae and fly maggots. If that area was cleaned out or otherwise kept dry, it would not be suitable for fly development. The pen or the feed trough here in the center, nice dry feed trough on the inside, but we have a water drainage situation here, and then the bedding has been soiled. The bedding has enough moisture in there. This is a fly breeding area. Underneath waters, check for leakage, check for things that are going to give you that moisture, clean things out on a regular basis. Other prime breeding areas, I think it's basically a walk through the barnyard and see what's there. We have a couple examples here where a lane has an accumulation of debris, manure, straw, spilled feed and such, perfect for growing, for growing fly maggots. Sanitation underneath the feed distribution areas, if that area is kept clean, it's going to minimize potential risk. And one other thing might be to mow the areas around the barnyard, just removing habitat. Habitat for the flies, habitat also for other things such as rodents. Stanchions or free stalls, I imagine most of our, if we have animals, they're probably in a stanchion or in the calf pens. But basically, are those areas that are hard to reach developing flies? Is it someplace that we can think about getting into, cleaning out on a regular schedule? And if we think back to the fly development, where warmer temperatures, houseflies can develop in as few as 10 days or less, we want to break up that growth every week, more frequently if possible, cleaning out pens and such as often as we can. Some of these, the barn design is going to allow you to do that more frequently and more easily than others. Talk a little bit about stable flies. Organic matter is key for their development, but this is also one of these flies that not only is going to develop in confinement areas, but also comes in from outside. And it comes in on weather fronts. If you noticed that you were not getting bit, but then a storm front comes through, and then your animals are starting to get agitated. They're biting their lower legs. You're getting bit yourself. This is probably a stable fly. Some places where they can be breeding on the farm would be around the base of big bales that are out in the field, where you have a soil big bale interface. That's good potential breeding ground. Untended compost areas that are not mixed are going to be another place where the temperature is going to allow, and the organic matter is going to allow them to breed. Lakefront or stream or seaweed is another place where these flies breed. And common to a lot of places where you have a round bale or a feeding kind of stock out in the yard, this is going to be a potential perfect place for fly breeding, stable fly breeding to occur. The slide on the far right here with the farm just tells me that there's a lot of potential other places that these can breed and that they would be coming in from outside. But we can do a lot to minimize stable fly breeding on our own operations. Let's talk a little bit about monitoring. How do you know if you have problems, and what can you kind of objectively do to help yourself to get that information? One of the things that we find when we have people coming up that have issues with their neighbors that are fly related is, how good a job are you doing on your farm? Well, you get into those conversations. This would be one of those ways where you can document your fly populations over time, and you can have a record for looking at fly development over the course of the summer. A very simple thing is called spot cards, taking a 3x5 index card. What you're doing is you're putting these up around the barn, as many locations as would be easy to handle, 10 or so. And what you're looking for is the flies have that behavior of going and resting on surfaces, and the nice thing that they do, of course, is defecate or regurgitate their food, leaving a nice spot. So you have these spots around the barn. On the spot cards, they will rest on those spots cards, and you'll have a relative indication of how frequently or how many times they were visited. We want to take about 5 or 10 of these cards and sample and change the cards on a weekly basis. This will give you an objective way to evaluate how the number of flies have been visited. Here's an example here. The fly was sitting there on the spot card, and a series of different cards showing different amounts of spots. For a lot of the research that we've been doing, we look at 100 spots per card as a relative indication of fly activity. On your own farm, you can adjust whatever you want up or down to your own personal threshold, but it gives you something to look for over time. One thing that we do then with that information, you can see on the left-hand side, we have spot card locations. I just draw a diagram so that I remember where those cards were. If they've fallen down, if I had the senior moment and didn't remember where they were, I could go back to those places. I'd look at the cards, and I can estimate after a period of time how many spots are on that. And I track that information over time. And you can see the graph that we drew here indicates that there's a couple locations where we continue to have issues, like on the lower area here, number 3, and then someplace around number 7, we continue to have issues. Those would be spots or areas within the barn that I'd look to see if I had breeding. So I could see if I had a corner that I keep missing that is a real source of fly breeding, I could go in and look at it. It might be a particular area in a stanchion barn that might have an older cow in it who's leaking milk and just happens to be attracting flies, but there's not breeding in the area. But it does help to kind of hone in on where are issues. Those are be for house flies as well as for stable flies. Some special ones for monitoring for stable flies, and the ones that we've been using in New York is we look at how many flies are on the animals. And these are standing animals, counting all 4 legs as opposed to Roger's 2, but basically looking at number of flies that are found on the animals. Our action guideline here is 10 flies per animal, and this would be that we would want to do something about that particular issue. Let's begin to kind of transition here into management alternatives. How are we able to bring an integrated approach to minimizing these fly problems in the confinement areas? The main thing, and much of what we can do for fly management in the confinement area, is going to be in sanitation, cultural practices, and breaking up that fly's life cycle. As Roger mentioned, moist organic matter, he called it heaven, I'll call it paradise. I think we go to the same place ultimately. But we have to do something to break up that fly going from egg to its an adult stage. So these would be things like cleaning manure, soil bedding, moist hay. Keeping things dry is going to be critical. And how can we do that? Roger also mentioned some of the issues that we can do with spreading manure, spreading it thinly so that it's going to dry out as quickly as possible. Controlling moisture. I always look at water sources, their automatic feeders, bubble feeders, whatever it might be. Make sure that there aren't any leaks. Good ventilation in a confinement area is certainly going to help to get drying conditions. Proper grading and drainage. Rain gutters on the outside of barns. Dumping old water away from the bedding, and this is particularly important for working with young stock. It's a lot of times it's easy to take a water bucket right from that cow pen and just changing the water, dump the water right there. Where's that water going to go? Is it going to go into the bedding and give you potentially moisture that's going to be suitable for fly production? I'd recommend taking those buckets away from that pen area where it's going to keep the pen dry. And change bedding as often as is possible to disrupt that larval development. If you have a calf situation where the animals are on that bedding for a period of time, keep it dry. Roger touched on this. I'll add to it a little bit. Can choice of your animal bedding material have an impact on fly production? Certainly it depends upon what's available and what is economical and what is practical. A couple studies that have been done, and Wes Watson here in the room did one of these. We're looking at sawdust versus straw and the number of housefly and stable fly larvae, and in a couple different trials here. And I think you can see pretty easily that the straw bedding has consistently producing more housefly and stable fly larvae than do the sawdust bedding. So if you had that option, certainly something to consider, lowering the potential breeding numbers of flies. Another one would be some work by Ed Schmidtman that Roger cited another example from Ed's work, looking at straw with the hardware cloth that you would use kind of maybe in the garden for weed control, and allowing some drainage, but we still have good numbers of houseflies and quite a good population of stable flies. comparing that bedding source to sand or also to gravel, sand and gravel, better drying conditions, less organic matter, and less flies ultimately being produced. Some other things, common things, certainly sticky tapes, ribbons, fly paper and such, screens around the milk house area, fly traps, and of course our organic folks, our insecticides. Basically we have Pyganic as a pyrethrin. There are different types of ribbons. Not everyone has probably seen at least one of these anyway, but the sticky ribbons that you pull out of the small circular cylinders, the ones that go on, the strings that go around the barn. One of the ones on the lower right-hand side is one that we've done some work with, which are very long sticky tapes. They're about 14 inches or so wide, and they can be anywhere from 8 to 24 feet long. They have a sticky substance and are attractive to the flies, really do a good job about collecting a large number of flies. Some of these things, it's a matter of where do you place them. Is it going to be in a place that's going to be free from getting bombarded by wind or dust or whatever, and checking the tackiness, how sticky are they over time, and how many flies are on them. It's just a little bit of monitoring those for their effectiveness. Common things in fly traps, certainly. We had one on the far right here is one that could be used around the barnyard area. It's called an alsonite biting fly trap. It's a type of a special kind of fiberglass material that gives off a wavelength that's very attractive to stable flies. And if it will have a clear sticky fly paper around it, and under the right conditions, it can do a lot to knock down stable fly populations. The material that you see here is an example of the different types of smaller traps that are also attracted to stable flies that can be used in a confinement area. The center one here is a Terminator or a wee stinky trap. It is particularly good for house flies. You could also catch some other flies. The one thing with these traps, they are attractive to flies, and hopefully you put them in a place where you're catching your own flies and not attracting flies from off-site to come and visit your particular fly trap. You don't want that to happen. I'll kind of begin to close down here with biological control. And we've already heard a little bit about there's a lot of different things that are active in the barns already in these confinement areas that are helping us to minimize fly production. We've heard about the predaceous mites. You can see the things in the upper right-hand corner here that are white and look like rice. Those are probably about a 1/16 or so of an inch from end to end. Those are the fly eggs. And the small red beasts that you see here are predaceous mites, these macrocheles. Other things that are feeding on eggs and larvae, there's a lot of things like these predaceous beetles, these carcinops beetles. And it's not only insects that are helping us out, but it's also diseases such as Beauveria that you see. If you see fuzzy flies up in the windows or on the windowsills or in the barn, or that might be stuck to a wall or so, and they are fuzzy, this is a disease of that fly. And the disease can be transmitted fly to fly by animals going over and seeing, oh, somebody here they're slow, they're not moving, it looks like they need some help, I'll go and visit. And in doing so, they get the spores that are on this fuzzy fly, go over to the healthy fly, and then begin to infect them. And the one that Roger talked about, and I'll talk a little bit more about, there's a lot of activity about releasing parasites, those stingless wasps. And two that have been, that we're using here in the Northeast that they've done a lot of work in Cornell's veterinary entomology lab and Don Rutz's lab, is Mucidophorus raptor, and a new one, Raptorellus. We found that these are endemic to our areas, that they do a very good job, that you're going to find them you're going to find raptor naturally occurring on our dairy farms, and you can augment the population that you have by purchasing them through an insectary. Before using them, I think that people ought to realize and that this is not a silver bullet, the use of these beneficials, that really it builds upon how good a job we're doing in sanitation. 95% perhaps of the fly management in these confinement areas can be dealt with cultural practices, manure management, bedding management, keeping things dry, and those types of issues. We can also then, if we did have adult flies in the area, we can look at the use of sticky tapes. We can use our monitoring to give us an idea about what areas need to be worked with. These parasitoids are in addition to those things, and they kind of help to clean up those flies that may have escaped one of our other techniques. And we would begin them early in the season, now in this warm season, thinking about doing our first releases in May, and continuing to release these over time. And one of the reasons why you do it over time is that they do not produce as many offspring, or it takes a longer period of time for those insects to develop compared to the typical housefly. We buy a colony essentially when you order these. It's sent to your door, and you distribute your colony throughout the barn. And you distribute them in those areas that would be the most likely ones to have larval development and survival. So in the corners of calf hutches, near feeding areas, these types of things. The cost of these is going to be a variable depending upon who you're buying them from and how much and such. But one possible thing to think about would be it's someplace around, you want about 10,000 of these parasites per week for a 50 cow or 10 calves. You want more per calves because the calves are going to have potentially higher numbers of flies developing in their areas, fewer in the cows. And for this is going to be one of those arts versus science things. If you have all your animals out on pasture during the summer months, you don't have them in barns as much as you would the calves. You probably only have to concentrate on the calf areas. But something to think about. One of the keys that you're looking at here is it's really a race for domination. And the domination is that these wasps are going to go out, seek out the housefly pupae or the stable fly pupae, attack them by either, they'll locate them, they'll drill a hole into that thing that looks like a pill, the pupal case. And in doing so, it can insert an egg into that, which then hatches and develops and eats essentially the housefly or stable fly. If they don't lay an egg, but they have drilled that hole, that provides an area that is susceptible then for basically that housefly pupa to dry out. So it's going to help us out. What the graph is here is it's showing housefly development over time, and you kind of get the feeling on that red line that the higher the temperature, the quicker your housefly populations are going to develop, and you think about all those eggs hatching, all of them developing over time. Well, the parasitoids that we're talking about, and the one that I'll mention here is Mucidiferax. It takes about 3 times as long to develop as a housefly. So it will begin working, but you'll need to have a longer period of time for that population to begin increasing to the numbers that will help to knock down the developing houseflies. So this is why we would want to put out weekly amounts of the parasites onto the farm. One of the things we've done, and this is work that was done a while back by Lincoln Smith and Don Rutz at Cornell, was what are the species that do best in your conditions? And this is some data from Lincoln Smith's PhD thesis. Basically looking at Mucidiferax raptor, you can see it does pretty well outdoors. It does well in certain situations in sheltered areas. It does very well also in indoors. So it was one of those things that gave us an idea that we would be looking at this as a potential biocontrol in our area. Now, for those of you in other parts of the country, I'd say if you're looking at using parasitoids, look towards people that are producing those in your area. Look for the best information you have of what would work best under your local conditions. This is I'm sharing information that seems to work quite well here in this part of the country. If you haven't seen parasitoids being used, what you have in the lower left-hand corner here is what you would get when you get a colony. Whoops, sorry. You can see the brown eggs or pupal stages here mixed. Those are the housefly pupae that have been parasitized by this wasp. That's done in the insectary. They are shipped in shavings. You get a bunch of already parasitized pupae, and then when you get them, you distribute them in the calf areas or in other areas that you suspect are going to have fly breeding potential. So we have them putting them over in the front of the calf areas where they're not going to be stomped on by the animals, in hard to access areas that are just difficult to clean, in areas that had potential to be moist organic matter. I wanted to just include a little bit about a study that was done a while back on putting this whole integrated program together. And the program would develop around sanitation and cultural practices, and then the use of these parasitoids, the use of the monitoring that we talked about, and in this particular case, it was selected use of insecticides when needed. Now, this was on a conventional farm. This is quite a bit of time ago, but it gives us an idea about what would be the potential benefits for using this integrated approach. Study was conducted in New York and also in Maryland. On the graphs here, you can see spot cards. Remember those on the left-hand side, and then weeks along the edge here for the growing season. The solid dots are going to be where we released parasitoids. I'm sorry, the hollow dots would be non-parasitoid releases. So you can see what you want in this is going to be lower than 100 spots per card. And in New York here, you can see that where we released the parasitoids, they had a lot lower spot cards number, give us an idea about population development. Similar type of trend in Maryland. Additional information here, this would be fly pupae that are parasitized, where we actually collected things, reared them out in the laboratory. In this case then, a higher number is going to be better. This would be the number of parasitized pupae is higher in those released areas than in the controls for both New York and Maryland. This is another indication of fly pupal mortality. The higher that number, the more the parasites are doing their job, the fewer houseflies we have developing over time. When we looked at all of this and did economics on it, then we found that we were producing a lot less flies, as you saw there with the spot cards, but we're also using a lot fewer insecticides. The cost of materials when you're doing insecticides versus the parasitoids are going to be something to consider. Ultimately, we wound up using, we cost less money doing the bio-based with that integrated approach than we were if we were using a conventional program with insecticide. The other advantage, of course, is that we aren't putting a lot of stress on the housefly populations or stable fly populations that could add to the development of insecticide resistance. So I think that the key here is that if we do it right with this integrated approach, basing it upon the cultural practices, looking at water, looking at bedding, looking at monitoring and such, and then consider, where it's appropriate, the use of these parasitoid releases that can help us out in knocking down fly populations, keeping down the breeding population to a number that would be acceptable on the typical farm. I will mention briefly here, there is a new species that's become available over the last several years that some of the research is more and more as time goes on. This is this M. raptorellus. Raptorellus, it's the same genus as raptor, and they have similar traits, similar biologies and such. The difference is that the raptorellus, instead of having one insect come out, one of those parasitized pupae, like raptor would do, raptorellus can produce numerous. They can produce 2, 3, 4 numbers of these little wasps out of one of those infested or parasitized pupae. So the population of those things can grow larger over time than the raptor. There still are studies underway to explore those more, but it looks like it has a pretty good potential for use here in the Northeast. I'll just mention very quickly, chemical control, certainly for organic farmers. We're all familiar with this 205, 206E, that you only use materials when you've basically exhausted all your other options. I think folks are very familiar with these, and we know that we do not have a lot of other options, insecticide options, in organic situations. Limited number of pesticides. Certainly, state by state, this is going to be something for you to look at and see what is available in your location. And I think the key, certainly, that the mantra that we often have is always check with our certifiers, see what's available, and also check with other neighbors. What's working? And one of the things that I think we would admit, keeping records is a good idea. Looking at how things are working over time is going to be extremely important. We do have a number of places to look for what has been registered, Omni approved, if that works for you. And one example is this is a table out of our dairy IPM guideline that's available on the New York State IPM website. But one of the things that is not as strong is how well, although these things are listed on their labels and such, grower testimonials on how well are they working for you. There's not a lot of research information on that. I think it's an area that would be extremely helpful for all of us to have better information on that. But they are available, and certainly a place to begin looking to what you could do. So I'm going to summarize here. We talked a little bit about economic losses with Roger's comments. We had discussions about off-farm movement. We had some discussions about the issue of insecticide resistance. We've talked about housefly and stable fly biology. Some of the ideas that we have for monitoring. We talked about spot cards, as well as looking at stable fly management, looking at how many flies on those animal legs. We've had some discussion about these management options. I did want to say that there are a number of resources that are available. Check with your local state or land-grant university as one place to begin, other sources as well. I have some information here on New York site sources. And I just say for the New Yorkers and for folks in the New England area, our IPM website, we have one of the few veterinary entomology groups in the country. Roger from University of Minnesota, Wes Watson from NC State, or two others. But it's really not something that you can find everywhere. But check locally. And on our site, we have a number of fact sheets that you can download. There's information on organic IPM, and this goes into what we've talked about in this morning's presentation. There's an eOrganic webinar that we did last July on Pasture fly IPM. Another thing that I might call your attention to, if you're still having trouble on what is that fly, the Cornell Veterinary Entomology website has a nice section where you look at your animal of interest, dairy cattle, beef cattle, whatever it might be. You signal on that, and then it brings you to kind of a decision tree. So I'm finding this as a pest on my pasture animals or on my barn animals, and it brings you down to correct identification, which is really the key for where you would go into your next steps of management. And with that, I think I'll end. Heather, special thanks certainly to the people that I've listed here. Don Rutz, our veterinary entomologist, Liz Thomas, who's done a lot of work with the organic guide for IPM, Phil Kaufman down in Florida, Wes here in the room, NC State, and Chris Gedden, USDA. So thank you. Yes, sir.
You haven't really spoken about bumper silage. I store all my feed, silage, and silage. It's pretty much gone by the springtime and we add to it and stuff. But there's nothing you can do pretty much what goes on underneath that plastic on the edges.
Yeah.
You can't disturb that.
Right. And that's the question is, what can we do about bunker silos? And I would think one of the questions that I'd ask you then is, does that appear to be a source of flies?
Yes.
One of the things when I see bunker silos, I look at the edges as you described. Is it a moisture thing that I can take care of? Is it better drainage? Is it something that I can remove that and put it in that area that seems to be affected and put it into an area that could dry out? One of the suggestions we have for manure piles, in some operations, they would put a pile up and it would not be something that they'd get to spread very quickly. Putting black plastic over it with heating it up. Along the edges, I think that's, what is the fly that we're talking about? It's probably the first question that I ask. And keeping things dry is the key. Removal on that schedule to remove those, if it was a developing area, that would be a consideration. I don't know if Roger or Wes has an additional suggestion. Roger?
Where you travel, you have to make sure that it's actually producing these flies that you see.
Oh, I see the little pupils.
Okay?
The old
See, maggots usually produce there. I've seen a lot of situations where the leakage stores these springs in and goes and grew up elsewhere. So just make sure that people are certain
Yeah.
that production problem is solved. And then go to black plastic or drainage, whatever happens.
Rogers.
Silo has plastic covered tread on the tires, which you're talking about. Yeah. But it comes down to the edge where you have your cement wall.
Yeah.
Under the plastic. This is your store peak. You can't take that plastic up and remove that raw
No.
material.
I suspect.
It's long term. First cut sits there and starts spoiling in 3 days.
Yeah.
And it's there 100 yards from my yard. And the only thing I can think to do is put parasitic walks all around that.
The suggestion that some of you out in on the web there didn't hear was Roger's suggestion was to sample with the trowel, which is what I had mentioned. I think that there is some potential if that is a site that is continuing to breed flies. Parasites could be possible there, depending upon what type of fly it was, and if it was in a sufficient number, it could be that would be a location for a trap, such as a biting fly trap, for example. Other than that, I'm not sure we have the ultimate answer.
My neighbor has bunker silos, and in the past they put a layer of plastic on the wall of the bunker and then put their feet in, and they kind of tuck that in so that it's basically for spoilage. Yeah, but I would think we'd do the same thing for the fly control if the fly can't get to the material. And they found that to be pretty effective, and they also do on a forage drain pipe down at the bottom of the wall to try to allow any liquid that's going down in there to get out.
That's a great idea.
Good suggestion.
Just one more thing, Roger, and then we'll.
I see these big foot diameter sausages that they lay out on the ground to keep construction debris from rolling on the protected areas. I wonder if the guy couldn't get a couple hundred feet of that stuff and anchor down the target that's around the edges to keep it from spoiling. If it's not spoiling, it's not required.
Yeah, what the neighbor has done in the past is used some of the material that he used to cover the pile initially, save out some big chunks of it to use so that he's kind of, not having to be expensive.
Great. It's a great idea, and I think we can continue with the discussion after lunch. Thank you very much. We have one more speaker, and we want to give Dr. Watson his time as well. So hold on to your questions. So thank you, Keith, and I don't know if very good information. And so our last speaker today, or this morning, is Dr. Wes Watson, and he is a professor of entomology at North Carolina State University. And of course, his research is focused on the management of livestock and poultry pests. So, Dr. Watson, thank you. Hand it over.
Thank you for inviting me. It's nice to be back in the area. You saw from the slides earlier that I was affiliated with Cornell University for some time before moving to North Carolina about 15 years ago. Since moving to North Carolina, I've had some new pest issues to deal with. My commodities that I concentrate on include cattle, dairy production, beef production, swine production, turkey production, chicken production. So I get just about everything that's in the state. Interesting. There we go. Good. All right. At the outset, I'd like to give some acknowledgments. Steve Denning is my technician. He's a great resource. He's phenomenal. He's an engineer in the rough. Lena Geisweit and Jonathan Kamek are my current students, both working with me today. Kevin Anderson is a veterinarian, runs the mastitis laboratory at the College of Veterinary Medicine at NC State. Roberta Lyman is Kevin's right hand, and she does most of the mastitis work for our program and for the state. Steve Washburn is a dairy specialist in animal science, a great resource. I work with Steve quite a bit in dairy production in the state. Andy Meyer is the superintendent of the NCDA farm that we do most of our work on, located in Goldsboro, North Carolina. That farm is also called the Center for Environmental Farming Systems. It's a great resource. We have an organic dairy herd on that farm, as well as a conventional beef herd, and we have goats. We have a number of other animals there. So this is fundamentally a collaboration between NCDA, North Carolina Department of Agriculture, NCSU, our university, and North Carolina A&T University, which is a historic black college and university that's in the state. So all of us get to work together in these projects, and what you're going to see is a reflection of all of our efforts. With that, as you've already seen today, this is where it all begins for us. The common pests that we have are the same as you've already been presented. We've got the housefly, facefly, stablefly, and hornfly. Most of what I'm going to be talking about is in the pasture setting, and you don't typically think of the housefly as being an issue in the pasture setting. But this photograph was taken in a pasture. These cattle had been given some supplemental grain in the portable feed bunks, plastic bottom feed bunks. There was significant fly breeding going on around those feed bunks, and so we had houseflies breeding in that area, and they were also feeding on that grain in a pasture. Face flies, this is an Angus animal we've got right here. This is located in our part of North Carolina. If you go west from Raleigh and go up into the Piedmont region, as well as into the mountains of North Carolina, you find a significant number of face flies in that particular area, including on the dairy herds that are around that part of the state. Stable flies, this is a photograph taken in a pasture. These are stable flies feeding on the legs of a pregnant heifer, and this is the horn fly seen right here, and this is without a doubt the most serious fly problem we've got in the state. To reiterate, a lot of the discussion that we've already had today, integrated pest management utilizes a lot of different angles to try to manage these pests: cultural control, biological control, mechanical control, and chemical control wherever it's feasible. For us, managing these flies in the pasture is very difficult, and it's kind of hard to implement those integrated pest management strategies in a pasture setting. As I mentioned, the horn fly is our most serious pest, and you can see on this pregnant heifer here that we have a significant number of flies on this particular animal. As Roger mentioned earlier, it's a pasture-bred fly. Pasture-bred fly that was traditionally controlled using ear tags, but it's a very difficult insect to control even with insecticides today. Hematobia irritans, that's a scientific name. It causes a lot of irritation and annoyance for these animals. Female produces about 20 to 25 eggs per day. Feeding habits include blood feeding. They can take 10 to 12 blood meals per day, sometimes more than that. You also see in this picture that we've got a significant number of flies right here. And if you're trying to count or quantify those flies by sight, it's a very difficult thing to try to do. Roger mentioned that in the past, we've always, in the textbook, said that the horn fly existed on the backs and bellies of the animals, and these are not stable flies. These are horn flies feeding on the lower legs of a Holstein animal. I guess maybe it's not a Holstein. It looks like it might be a Jersey in North Carolina on the farm that we're dealing with. And that's a tremendous number of flies feeding on this particular animal. Typical population curve. In the spring of the year, they break diapause. For us this year, we start seeing horn flies in early March, and they've been on the increase ever since. In the fall of the year, our populations typically drop off as they begin to go into diapause, and most of the adult flies at that time are geriatric flies and are not going to be contributing to the population as much for that particular year. Monitoring the flies, as I mentioned, is difficult to count sometimes. With a trained eye, you begin to get a sense of how many flies are actually present. In this particular slide here, we're looking at about 450 flies on this animal here. Cultural control, we talked about that. With IPM, it's kind of a difficult thing to think of when you're talking about a pasture. How do you induce a sanitation effort in a pasture? And one of the things you try to do is reduce the habitat. We've also talked about biological control, and as Roger pointed out, there's a number of challenges when it comes to augmenting your biological control population in a pasture setting. Fly traps, walk-through traps, electrocution traps, I'll talk a little bit about those in the next few minutes. And in chemical control for organic production systems, there's very few pesticides that are available for us, but there's a real interest in using repellents, and I will talk about one repellent in particular that we've done a significant amount of research with. But before we go on to that, let's talk a little bit about the sanitation issues, and we've hinted upon this several times this morning already, and that is dung beetles. I've had two students, Matt Bertone and Elena Lastro-Nino, who were working with me on dung beetle projects at NC State. They did a significant amount of work for us and gave us a lot of insight as to the potential benefits of dung beetles. This is a drawing that Matt Bertone created indicating the different types of dung beetle nesting behaviors that occur in the typical dung pat. There are three different nesting behaviors that fall into these categories. Let me see if I can pull these insects out. These insects are all tunneling beetles. The tunneling beetles are the beetles that frequent the dung pat. Working in pairs, they excavate soil, they dig a tunnel underneath, they pack that tunnel, they create brood balls down below, they recycle soil, so they take subsurface soil, they move it back up to the surface, they take surface soil, they move that back down into the tunnels. These dung beetles are ecologically, in my opinion, the most significant beetles in improving your pasture ecosystem, mostly because they're very much involved with recycling of nutrients and organic matter. They increase soil percolation. We have red clay soil in North Carolina, and it compacts really hard, and dung beetles can break through that, and they can do excavation, and they can really increase your soil permeability. Another group of beetles that we have are called the dwelling beetles, seen right here. These are beetles that shred the dung pat. They break up the dung pat. They will oviposit in the dung pat itself, and they cause a lot of decomposition. But when it comes to brood and burial and tunneling, they're usually relatively shallow, and so they just go down maybe an inch or an inch and a half into the soil. And so they don't make a significant contribution to percolation of the soil or integration of organic matter, but they certainly do shred the dung pat, and they do break it up a lot, and they make it unusable for flies. And then the last group of beetles, which seem to frequently get all the press, are the rolling beetles. These are beetles that will excavate the dung pat, they open it up, they roll balls of dung away, and then bury it shallowly. And their contribution to to actually the pasture ecosystem is probably significantly less than the other two groups of beetles. And for many of us, they're usually the coprous beetles that are involved with that. So over here, we've got Phanius vindex. This is a native dung beetle. We've got Ontophagus. These are Ophodius and Labrus beetles seen here. They're dwelling beetles, and coprous beetles are the tunneling beetles. So, is it sanitation? This is a good example of one of our pastures in North Carolina where we have an abundance of dung beetles. We've got about 25 different species on the farm, and you can see all of those dung pats in that pasture. They're all over the place. This is a photograph taken in Australia, taken by John Feehan, and you can see where they did not have many dung beetles, that there are lots of dung pats left around contributing to pasture fouling. And that's an issue that the dung beetles are able to actually solve on most of our pastures. How quickly do they remove? These are two groups of dung beetles. We have 20 dung beetles in here. Ontophagus taurus was the species we were dealing with, 50-50 males and females, 20 beetles in each pot, 3 days of activity. This is the first day of activity, right when the beetles were dropped into it. Then this is the third day right here, and you can see how effective 20 dung beetles shredded that dung pat. It clearly shows that these beetles are able to have a negative impact on potential fly breeding sources. I mentioned soil permeability. These holes that you see here are where the dung beetles have burrowed into the soil. Soil cycling. These are pictures here of the subsurface soil that's been brought to the surface. These darkened areas that you see right in here are the dung pats themselves, but all of this is subsurface soil that's been lifted and taken up to the surface. So is it biological control? And this is an issue I deal with frequently. I'm not absolutely certain that it's biological control because these beetles don't have a direct impact on the flies that are breeding in the dung pats, but they certainly compete for resources. They compete with horn flies, face flies, and there's a strong indication that in the process of burying dung that they put the gastrointestinal parasites into the soil, and they have less chances of reinfesting animals later on in their development. I mentioned we had about 25 different species in North Carolina. These are the major players that are involved, and here in this large part of the pie chart here, 65% were Ontophagus taurus. This is the most abundant beetle that we have. It is a tunneling beetle, and it's a significant contributor to our dung beetle fauna. Some of the other species that are here, this is a dwelling beetle. This is Ophodius lividus. I think the name is now changed to Labrus pseudolividus, and a couple of other species that are involved. This is a slide that Keith provided me earlier showing some of the species that are available in this region. Ophodius erraticus, we also have in North Carolina, makes up a significant portion of the population. I believe that's right here. Then we've got Ontophagus taurus, the same one, approximately 26%. For us, it's 65%, significantly less here. But over here, we've got Ophodius sticorus, 22% here. Looks like 11%. Perhaps that is Scaraboides. I have a little difficulty because I am colorblind. So a little bit on the biology of these. This is a major player for me. Ontophagus taurus, it's a dominant North Carolina species that we deal with, 5/16 of an inch in length. It has bull-like horns on the male. You can see these horns that are all wrapped up right here. The males are very distinct. It's very easy to recognize them. This is a female, no horns present on her. 2 to 4 generations per year. It's active from March to November, and these are the contributing factors. Percolation of the soil, they compete with flies, they reduce pasture fouling. These are a couple of natives. This is Ontophagus hecate or hecate. Seen right here, the males have this prodromal process right here that sticks out over its back. over its head from its back. It's a very distinct feature. You find that beetle and you recognize it right away because there's not another in the country that looks like this. Here's a female. This is Onthophagus pennsylvanicus, 1/8 of an inch long, active from March to November. So it's a major contributor for us in North Carolina as well. A couple of dwellers, Aphodius pseudolividus, came over with the colonists from Europe. Aphodius erraticus, this is a very beneficial dung beetle. These beetles shred the dung pats, they break them up readily. And so those are the basics on some of the dung beetles. We have a diagram, or we have a handout in the back of the room, and there's also a website that you can go to look at dung beetles from North Carolina and around the country. And because their distribution overlaps with a lot of different areas, it's worth taking a look at, because I believe a lot of the beetles that you have here are also included on that handout. Other benefits of dung beetles. Alina Lastro-Nino conducted a study to mimic a rotational grazing system. She wanted to see how the dung beetles would contribute to the overall growth of grasses in these pastures. She wanted to simulate the grass growth period, grazing period, deposition of dung, and then cattle removed to a second location, and then have a new growth period, another grazing period, deposition of dung, and then cattle moved to a second location. So basically it was kind of a rotational system. This was her experimental layout. These are the different kinds of soils that she was dealing with. She had clay, loamy soil, and sandy soil. So she had manure alone treatments, manure plus dung beetle treatments, and then a fertilizer treatment. These were some of her results. And as you would expect, depending upon your clay type, the benefits of dung beetles are going to vary a little bit of your soil type. In clay, for example, dung beetles, this is dung plus Onthophagus taurus, was a great benefit. We had a significant improvement in the dry weight of our ryegrass, pasture grass here. And then when you see sandy loam, the dung beetles were not quite as significant as in comparison to a fertilizer. In sand, the dung beetles were superior to a fertilizer. So overall, this is kind of an average of all three soil types right here, showing that the dung beetles made significant contributions to the growth of the ryegrass pasture system. That pretty much held over for Sudan grass, which is another common grass that we use during the summer growing season. Now, Roger talked a little bit about walk-through fly traps, and the concept's been around a long time, since the 1890s. He talked about Bruce trap. Bruce did a lot of work with this in the 1940s. Hall and Dozy did some work in 1989. Tozer and Souther in 1996. And then Moreland, Miller, and Pickens patented an electronic or a bug zapper design on a walk-through fly trap in the mid-90s, if I remember correctly. The reasons you'd want to use a walk-through fly trap is you've got an abundance of flies, you're convinced of economic losses, you've got some concerns about animal welfare. This is one of the issues that happens a lot, is that people look at our farms and they see all of these flies on the animals and they think to themselves, why don't you do something about it? Well, this is one opportunity for us to actually try to do something about it by using a walk-through fly trap. The other reasons you'd want to do it is you have few or no insecticidal options. You're either dealing with insecticide resistance on a conventional farm, limited no new products, regulatory issues are out there, and of course, if you're an organic grower, you're very limited in the kinds of insecticides that you can use. We did some early work with the Moreland style trap. This was a large walk-through fly trap that you could set in an alleyway on a dairy. You can see that it spanned the entire width of the dairy. It had curtains in between. You can see here that there's a curtain missing from the middle. The reason we did that was so that we could get the animals acclimated to using it. If the animals were able to see through it, they started to go through. Then later you add curtains back to it until it eventually looked like this one that you see down here. The trap included 2 large industrial-sized bug zappers that were in the ceiling, and 2 bug zappers that were located in the walls, one on either side. The cattle would walk through, the flies were brushed off, they would move up into the bug zappers and get electrocuted. The bug zappers had black lights in them, and so the flies were attracted to the bug lights, to the black lights as well. This shows you the cattle walking through on the way to the parlor at the Center for Environmental Farming Systems. And these were some of the results that we had with our trap dating back to 2000. We waited until the fly population became a concern. This red line that you see right here indicates an arbitrary economic threshold level of 200 flies per animal. We wanted to be sure that we were well above that, so we were nearly 1,400 flies per animal on these on this herd when we activated the trap. And in just a few short weeks, we actually dropped that population of flies down. It was quite remarkable to see because if you did it late enough at night, you could see the sparks flying from the flies being zapped with this device. And it held out really well that first year that we used the trap. And then the second year we used the trap, it didn't work quite as well as we had hoped. We had a few days that were below, and it seemed to hold up later on in the season much better, but then so too was our natural fly population in decline as well. One of the issues that we had is that we kept burning out transformers, and in the end it was costing us about $1,000 a year to maintain the trap, keep it going. One of the issues was that the trap would be left on at night. So what happens when you leave something with black lights on at night? You get lots of other things coming into it, include millions of moths. And so this thing was working and working and working, trying to keep that moth population down and not contributing at all to fly management. So one of the things that we wanted to do is try to figure out a way that we could manage flies in another way. And Steve Denning, who I mentioned early on, began to think that, well, one of the things with the other walk-through fly trap was that the flies were responding to the black lights and getting zapped in that system. Well, he thought, what if there was nothing there for them to actually respond to? What if you just disturb the flies and then suck them out of the air? And so Steve invented, I mentioned he was an engineer, he invented what we commonly refer to as the cowvac. This is a system in which the cows walk through and the flies are sucked off of their body. Over a course of the year in 2007, we collected 2.4 million flies removed from these particular animals. This line here, this graph here, shows the numbers of flies that were trapped during that time period versus the numbers of flies that we counted on the cattle themselves. That's the blue line that you see here. And you can see that we were able to keep that population quite low on these animals, less than, in several instances, we were less than 100 flies per animal, sometimes into 50s on our fly counts. This is what the system looks like. The cattle walk through here. This one we have set up at the exit of the parlor, but it goes just as well at the entrance of the parlor. The system pulls the flies off of the animals. They are trapped up inside of the unit itself. And then when the unit is shut off, the side opens up right here and the flies come out. They emerge from here and we can actually collect the flies in bottles. And then we are able to quantify the numbers of flies that we actually collected off of the animals at the same time. Let me see if this works. These are animals using the cowvac. It's adjustable for height of the animals. You can see that the animals here are of various heights, some tall, some short. So it is quite flexible, and you've got the animals that are walking through. It pulls flies off of the top, off of the back of the animal. It also sucks flies off of the belly of the animals. So I think it's going to stop. There we go. That's the end of that one. So in 2007, we collected 2.4 million flies from 180 cows. It cost us to operate the machine 6 cents a day per herd. It's pretty cheap. In 2008, we collected 1.9 million flies. We had a mean density of 100 flies per animal on the vacuumed cattle, and we had on the animals that were the control animals, we had a density of 479 flies per animal. In 2009, we collected 2.35 million flies from those cattle. We had a mean of 167 flies per animal on treated cattle, with the untreated cattle of running about 671 flies per animal. So the CalVac system exists out there. Places where we need to do research. This is in eastern North Carolina. We don't have a great face fly population there. We do have stable flies. We were able to catch stable flies with the device. We don't have any data really at all on face flies, but we do know that on occasion we pull up face flies in our collections. The other thing we need to do is actually compare it to the passive trap. You saw pictures of the passive trap before. This is a shot of a passive trap here. Has a double screened walls. The flies get trapped inside. They work their way through these small openings in the baffle where they die of desiccation on the inside. So that is one of the things that we really need to do, is to do a direct comparison and see how the two traps work. Now the last aspect of this, and I hope to stream through this pretty quickly, is looking at repellents. I've done a lot of work with geraniol. Geraniol is a plant-derived monoterpene. It's also called palmarosa oil. Organic geraniol is steam distilled from the flowers of Cymbopogon martini. It's a grass that's grown in Nepal and India, and in some places it's also grown in California. It's recognized as an insect repellent. Native peoples in Nepal and India have known this for hundreds of years, that it works as a repellent. It's also considered to be a minimal risk active ingredient, generally recognized as safe. It is currently listed for use by OMRI, so that you can purchase it through OMRI. One of the things that we wanted to do is figure out what might be the most effective dose for a bovine. And we were using initially a 30% geraniol product. We looked at 60, 120, and 180 cc's of geraniol per animal, compared that to a no treatment. These were our mean numbers of horn flies on animals that were treated for the season. The control group was about 360 or 70 flies per animal. At 60 cc's, it was significantly less. 120 cc's, less yet, and 120 cc's, just a few flies per animal. There were no significant differences, though, between 120 and 180 cc's in those treatments. So fundamentally, for large, mature animals, we look at 120 cc's per animal as a treatment. For smaller animals, 60 cc's is all that's necessary. One of the things that we have in North Carolina that's a real problem is teat damage in heifers. Horn flies feed on heifer teat ends frequently. It predisposes these heifers to Staph aureus infections. Kevin Anderson at the Mastitis Lab has identified genotypes of Staph aureus that are identical in the horn flies. They are different from a lot of the Staph aureus that you find on workers and things like that, but exactly the same Staph aureus is in the horn flies. Feeding of these flies and infection with Staph aureus ends up with heifers having dry quarters. They have to be sold before they can be bred, and it's an economic loss of at least $1,800 a year in eastern North Carolina for dairy producers. We have a scoring system looking at the teat ends. We have no damage is a 0, 1 is scabs present and healing, 2 scabs on the ends and they're bloody, 3 scabs covering 3/4 of the teat, swollen teats and bloody, 4 scabs covering the entire teat, swollen teats, bloody, and a discharge present, 5 utter swollen discharge present, loss of teats and bloody lesions. To illustrate some of these, these are healthy teat ends here. This is a teat end. You can kind of see this is dark right here. That indicates horn fly feeding. This one's turned up, and you can see the scab on the end of that from horn fly feeding. Here's one that actually shows the horn flies in the process of feeding. You see the raw scabs on the teat end right here, and 2 flies present here. Looks like we've got 3 flies on this one over here, a large red scab, and inflamed on this one here. Front teat ends tend to be more a preferred feeding site, mostly because that's more accessible to the fly. Here on the rear teats, the legs get in the way and they kind of disturb the flies, and so they're less likely to feed on the rear teats. This is kind of a close-up of a healing scab right here. This is a close-up showing teat damage on all 4 teats of this animal. This is irreparable damage. This teat is completely gone, and this is all swollen and inflamed, and that animal has to be sold. We looked at 1% geraniol mixed in mineral oil for hornfly control. We had 2 different groups of animals. We had small heifers. Our pre-treatments are seen right here, 320, 473, and 290 in our pre-treatment group, and then we sprayed them twice a week, starting out for this time period, and you can see the reduction in hornflies on those animals that were sprayed twice a week using this mixture of geraniol, 1%. This is what it looks like when they've been sprayed. For our scoring system now, we've changed this a little bit. We've got a teat score. This indicates the left front, left rear, right rear. And so all zeros, this is a 1, 1100 equals a 2, so making a 1 to 10 score. So you can see how that comes up there. These were some of our data from last summer showing the small heifers, large heifers, and then the control group. These are the teat damage scores on the control heifers. You can see them dropping away here. Here's our small heifers and our large heifers right here. You see them drop away pretty quickly. So the teat ends recover pretty quickly once you start using geraniol. The reason that you see this decline here is all these animals are housed together, and by repeatedly treating 2 groups with geraniol, you see an overall depression in the numbers of hornflies later on. This is an automatic spray system. This is used on beef cattle. You can put geraniol in this kind of a spray system. It's solar powered, and you can apply it to the back and sides of the animals right here. And you can direct it a little bit better up under the belly by putting another spray nozzle down here on the ends right here. So in review, integrated pest management, we've had lots of discussion about that today. Monitoring your fly densities, understanding how many flies you've got out there and what your fly really is. Biological control, how do you conserve them? What can you use? What can't you use? What works? Cultural control and sanitation, we've talked a lot about that. Minimization of resources for the flies themselves. Mechanical control, using traps. Chemical control, using essential oils for organic production. Pyrethrum when you can. And try to conserve those things that work. You know, those insecticides that do work, use them for the most important situations that you're in, the most dire straits, you might say. And then also try to conserve your natural enemies and competitors in that system. So that's the end of my presentation. Thank you.